This is a demonstration of how to use MrModeltest version 2 to estimate models of evolution for character partitions created in a NEXUS file. I start with the Win32 version of PAUP to both edit data blocks and run the first step in using MrModeltest. The following is an overview of the steps we will cover here. First, create the character partitions or sets in the NEXUS file. Second, we will execute the NEXUS file in PAUP. Third, we will isolate the partition that we want MrModeltest to estimate a model for. Fourth, in PAUP, we will execute the MrModeltest file called MrModeltBlock, which will evaluate 24 different models and select the one best suited to your current partition. This will create a file called MrModel.scores. This MrModel.scores file will be used in the MrModeltest application to create a file that will include the PAUP and MrBayes commands that can be pasted into your NEXUS file. You should be careful with MrModel.scores file because every time you run this, it will overwrite that file. The first thing we want to do is open the NEXUS file that we want to edit and run MrModeltest through. So open. I've created a file called sample.nex, and make sure you click on edit before you hit OK because we want to make some changes to this file. So edit, and you can scroll down past the data and into the sets block where you can see 5 partitions I've created, one for CO1, one each for the 3 codon positions of CO1, and one for 16S. So I'm going to move this over here so we can see the names of these sets. And the first thing we want to do is load CO1 only into the PAUP memory, essentially exclude all the others. The quickest way to do that is type include, and you can abbreviate the commands CO1/only. The slash only tells PAUP that you only want CO1 in the buffer or the memory. You hit enter and it verifies that there are 606 characters now included. We can check here that CO1 has in fact 606 characters. The next step now is to load MrModeltBlock, and that is usually in the MrModeltest directory, but I've moved it into here to make it easier. You're going to have to move the file type to all instead of next because it does not have an extension. So let's scroll to MrModeltBlock. There it is, and you can see it has no extension, so it won't show up unless you get rid of the file type extension. And you hit execute, and you can see it'll now evaluate all 24 models for the CO1 partition. Right now it's on model 4 of 24, and it'll click through for about a minute and a half or 3 minutes, of course depending on the size of your data. And once PAUP has finished processing the MrModeltBlock file, you will see this output in the PAUP display window indicating where the files have been saved, in this case in the phylogenetics folder. And we will now take the MrModel.scores file this is just created and run it through MrModeltest. So let's do that now. Okay, to use MrModeltest on Windows, you're going to have to use the DOS prompt. And the easiest way to get that is to go to Start, go to Run, enter CMD. Okay, and there's your DOS prompt. And the easiest way to interact with the DOS prompt is to open the directory that contains the files you want to process. In this case, we want to process MrModeltest2.exe or execute that file, and the format is the executable, and then in brackets pull in the MrModeltScores file that we created in PAUP just now, and create a space after that and provide a name that indicates what your model is. I call it my CO1 model.txt. Hit enter, and it tells you right away that the program is finished and that it stored it in the H drive. So let's go have a look at that file. There's the file, and we'll scroll down past the AIC criterion, which is right here and near the bottom. And you'll see here for the PAUP command block, it is conveniently created a little command block that you can copy and paste into your NEXUS file. There's also a command block for MrBayes, and you can do the same thing if you're going to do a MrBayes analysis. So let's go to our file, and we'll paste it in there. And now you can create a maximum likelihood analysis using this particular model.